Hi everyone. In the last video, I talked about heapifying. So if you have this input, you can create a heap by heapifying. And I also said that the time complexity is big O of n, but I did not explain as to why the time complexity was big O of n. So let's look at that now. So here, if there are total of n nodes in this tree, how many nodes are there in the leaf level? In the last level, how many nodes do we have? We have n by 2 nodes in the last level. If there are n nodes in total, what about the node row just before that? That row would have half of the number of nodes there in this node, so that would be n by 2 divided by 2, which is n by 4. What about the row right above that? Again, it would be half of the number of nodes in this row. So that would be n by 4 divided by 2, that would be n by 8, right? So if this row has n by 2 nodes, the row right above would have half of what this row has, so that's n by 4, and the row right above that would have just half of what this row has, so that would be n by 8. Right. Now let's look at each level one at a time. Now this is the last level. Here in the last level, how many times can we swap this value? Now this node has no child nodes, and when do we swap in case of a heap? When when any of the child nodes have a value lower than this one, but in this case, 6 does not have a child node, so it can't get swapped with anything. So the number of swaps possible for each of the nodes is in the leaf level is 0, right? For each of these leaf nodes, the number of swaps is 0. And how many nodes do we have? N by 2. So how many swaps possible totally for this level? N by 2 into 0, right? Now let's come to this level. Here at this level, there's only one level beneath it, so we can swap 5 just once, and same for 2, we can swap 2 just once. And how many total nodes do we have here? N by 4. So the total number of swaps possible at each level is 1, and total number of nodes available at this level is n by 4, right? So the total number of swaps at this level can be n by 4 into 1. For each of the nodes, one swap, total number of nodes n by 4, so n by 4 into 1. Now, what about this level? At this level, how many swaps are possible? Swap with level 1 and then swap with level 2. Say, for example, here the value was not 1, but it was 9, say. So, 9, we would have swapped that once, say not with 5, but we would have swapped it with 2 because 2 is the lower value. So, we would have swapped 9 once here, right? 2 would have gone here and 9 would have come here, and then 9 would have still been greater than the child node, so it would have got swapped with 3, so 9 would come here and 3 would come here. Okay, so the number of swaps at this level would be 2. So, and how many nodes at this level? N by 8. So for totally how many swaps would be possible? N by 8 into 2. So, what would be the time complexity? Time complexity would be total number of swaps at each of the levels. So, we add all the swaps in all the levels and we get the net total time complexity. So, that would be at the last level, total number of swaps possible is n by 2 into 0. Then in the level just above that, number of swaps, total number of swaps would be n by 4 into 1. Then in level right above that, how many swaps would we have? We would have n by 8 into 2. What if we had more levels? Then we could have just kept adding the total number of swaps at each level. So this would be n by 16 into 3. And then if there was another level, that would be n, total number of swaps at that level would be n by 32 into 4. and so on and so forth. What does this actually mean? So if we take n by 2 out, so we have n by 2 into 0. Again, I can take n by 2 out from here as well, n by 2 out from this part as well, n by 2 out from this part as well, and n by 2 out of this part as well. So if we take n by 2 common, what do we have? We first have 0. Actually, what can we say? We can say it is 0 uh, plus 1, 1 into, let me put this in brackets. So this is 1 into n by 2. Then I have 2 into n by 4, right? Because I've taken n by 2 out. So n by 8 becomes n by 4. Then 3 into n by 8 plus 4 into, let me put this in brackets. So 4 into n by 16, and so on and so forth. So what is 0? 0 is, we can actually write this, instead of writing just 0, we can write this as 0 into n by 1, and n by 1 is nothing but 2 to the power of 0. So this is actually 2 to the power of 0. Sorry, this is actually 2 to the power of 0. This is this is 2 to the power of 1. This is 2 to the power of 2. This is 2 to the power of 3. Sorry, 8 is 2 to the power of 3. 16 is 2 to the power of 4. Right? And so we have 0 into n by 2 to the power of 0, 1 into n by 2 to the power of 1, 2 into n by 2 to the power of 2, 3 into n by 2 to the power of 3, and 4 into n by 2 to the power of 4. So do you see this? There's 0, 1, 2, 3, 4, and here there is n divided, n by 2 to the power of 0, n by 2 to the power of 1, n by 2 to the power of 2, n by 2 to the power of 3, and n by 2 to the power of 4. So what is this series? This series is an arithmetico-geometric series. And for this arithmetico-geometric series, when n approaches infinity, the value of this entire series becomes 2. Okay, so what is the value that we have from here? The value what we have when n approaches infinity is 2. So if we cancel 2 and 2 out, what will be the total number of swaps? Would be n when n approaches infinity, right? So the total number of swaps, so the time complexity of heapification of heapifying it would be n, right? So when the time complexity is n for n elements, what would be what would it be in the big O notation? It would be big O of n. That's what we have here. So the time complexity of heapifying, of creating a heap by heapifying it, is big O of n. Thank you.